Hi viewers, welcome to the Sleepy Narrator, your calm corner to relax, unwind, and gently drift into rest while exploring the quieter edges of science. Tonight, we softly ask, what happens at absolute zero? At this ultimate cold, movement nearly halts, atoms freeze in stillness, and the strange principles of quantum mechanics begin to take control. Let these soothing science reflections guide your thoughts through frozen physics, quantum ground states, and the deep quiet of the coldest place imaginable. Whether you are here for peaceful science at night, gentle bedtime curiosity, or simply a calm escape into wonder, this tranquil journey will help settle your mind and bring deep rest. Close your eyes, breathe slowly, and let the sleepy narrator carry you to the stillness where even warmth fades away. Here at the Sleepy Narrator, curiosity takes the longer path, and even the coldest questions soften until they feel calm enough to wander through. Tonight, we step into a place so extreme it almost seems unreal. It is not just cold, it is the very floor of cold, the point where heat runs out of directions to travel. This place is called absolute zero. Perhaps you have heard the phrase before, in a movie or hidden in an old science book. But what it truly means is far stranger than it sounds. Because at that boundary, the very movement of atoms slows until it nearly vanishes. Time itself feels stretched thin, and the familiar rules of our everyday warm world start to slip away. But before we drift toward that frozen edge, let me ask something simple. Where are you watching from right now? Maybe you are curled up beneath a blanket in New York with the glow of a screen painting soft shadows across the walls. Or perhaps you are lying down in Tokyo, letting your thoughts settle like snow. Some of you might be in London, others in Sydney, or maybe even watching in quiet corners of Dubai. Wherever you are, if you would like this space to be where you let the day fade while still learning something fascinating in a calm way, I would be grateful if you gave this video a like, or even subscribed. It helps this small, peaceful corner reach more night thinkers who also want to drift through strange ideas as they rest. Now, let's take it slowly, because absolute zero is not just a temperature. It is an idea. And ideas like this have a way of reshaping how you view the ordinary world around you. When you touch a warm cup of tea or feel the cool air from an open window, what you are truly sensing is not some invisible trait called hot or cold. You are feeling movement. Heat is movement. Every particle, every atom, every molecule in your body and in the air around you is always vibrating and colliding. When it is warmer, they move faster. When it is cooler, they move slower. It is a tiny dance so constant and small that we never see it, yet it is present every single second. Picture yourself reducing that movement further and further, as though turning down the volume of a song until it becomes almost silent. If you continue, in theory there comes a stage where motion practically disappears. That point is absolute zero, negative 273.15 degrees Celsius, or 459.67 degrees below 0 Fahrenheit. Such values are so extreme they feel less like temperatures and more like challenges to reality itself. It is colder than the iciest corners of deep space, colder than anything you will ever encounter on Earth. In fact, it is so cold that it can never truly be reached. Because the closer you attempt to get there, the more nature keeps it just beyond reach, like a horizon that always pulls away. Still, even if we cannot touch it directly, scientists have devised ways to approach it step by step. And with each step closer, the universe behaves in stranger ways. Atoms stop acting like small spheres of matter and begin to resemble ripples in an invisible pond. Entire clouds of particles merge into a state called a Bose-Einstein condensate, a ghost-like condition of matter where the distinctions between one atom and another nearly dissolve, leaving something that shifts as though it were a single being. This is not simply cold. It is a new way of existing. It redefines how we understand the universe itself. At the edge of absolute zero, the usual rules of reality fade and quantum principles take over. These are rules that do not concern themselves with our everyday logic, with our sense of time, or with what seems reasonable. They remind us that this lowest mark of temperature is not just another point on a scale. It is an entryway to the hidden machinery of reality. But before plunging deeper, it is worth pausing to reflect on what temperature itself really is. If you have ever wondered why there is even a concept of zero in the first place, why there is a bottom to the scale at all, the answer lies in a time before thermometers, before scientific laws, when warmth and cold were merely sensations felt in the body. Fire comforted the skin, ice pierced through it. People lived by these feelings long before anyone realized that such experiences were linked to the frantic motions of invisible particles. Only after we learned to measure heat rather than simply sense it did the true scale of temperature begin to reveal itself. And at the furthest end of that scale, hidden within the deepest possible cold, lay a boundary no one could cross but everyone wished to comprehend. That boundary was absolute zero, and it represented not merely a number but the closest physics has to silence itself. In that silence, particles lose individuality. The randomness that fills the ordinary world quiets down, and order begins to seep in. There is something unsettling about this, because when motion slows so much, even the concept of time begins to shift. Time is measured by change, and at absolute zero, there is almost no change left to measure. Yet within that strange frozen stillness, nature hides some of its greatest secrets. Superfluids that move without friction, exotic quantum states that confound intuition, matter behaving in ways that feel less like ordinary physics and more like thought experiments come to life. This is why scientists design machines colder than the emptiest vacuum of space, not to freeze matter for its own sake, but because within that deep, quiet cold, the universe reveals a side of itself that does not appear anywhere else. And what is fascinating is that while this ultimate temperature sounds impossibly remote, glimpses of it shape your life every day. The microchips in your phone and computer depend on quantum behaviors first discovered near the shadow of absolute zero. The precision of atomic clocks, which synchronize GPS satellites so you can navigate home, rely on insights drawn from studying matter in conditions close to this bottom of temperature. Even ideas that sound futuristic, quantum computers, theories about the universe's origins and destiny, are deeply influenced by what scientists have learned from experiments that gaze directly into the abyss of cold. And as strange as it might sound, the nearer we examine this unreachable state, the less it seems like an end point and the more it feels like a mirror. Because at absolute zero, you are not just looking at cold. You are witnessing the limits of what motion means, of what energy means, and perhaps even of what reality itself means. So let us keep descending gently, 1 degree at a time. For the world at absolute zero is not empty. It is filled with quiet revelations waiting in the deep stillness, where the ordinary rules loosen their grip and something new begins to emerge. If absolute zero is the bottom of the scale, then this is the part of the journey where the scale itself begins to feel unreal. The phrase absolute zero almost sounds as though it was invented as a dare, a number so extreme it hovers on the edge of meaning. Minus 273.15 degrees Celsius. Not a fraction warmer, not even the faintest trace of heat left within it. Yet it is not simply cold. It is the border where cold, as we know it, ceases to function. A strange, unreachable frontier where temperature itself becomes a concept we can barely imagine. For most of our lives, temperature feels simple. We live among warm blankets and cool breezes, steaming cups of coffee and icy hands on winter mornings. Numbers we can make sense of. 40 degrees feels sweltering, 0 feels bitter, and we think we have seen the whole scale. But the truth is our everyday experience only brushes the surface of what temperature really represents. Temperature is not a sensation, it is movement. A measure of how much the smallest building blocks of matter are pushing and colliding like an invisible crowd. When things warm, those particles strike harder, spin faster, and vibrate with more energy. When they cool, the motion slows. But here is the strange twist. That slowing has no natural stopping point. There is no final rung, no ground floor to land on. Instead, every step downward costs more energy to extract than the one before it, until you approach a point where each fraction of a degree becomes an enormous effort. That is where you meet the idea of absolute zero. This concept did not appear overnight. It came from the slow progress of science centuries ago, when humans first began to realize that heat was not a substance you could pour or store like water, but rather something tied directly to motion. Figures like Lord Kelvin, who gave us the scale that carries his name, realized that if heat is motion, then there must be a boundary where motion itself ends. If motion ends, then temperature must end as well. That number became zero on the Kelvin scale, not as a mere convenience but as a border etched into the structure of reality. Yet here is the mischievous truth. While this number has a name and a neat place in textbooks, the universe will never let us touch it. No matter how ingenious our machines become, no matter how many lasers or magnetic traps we build, we will never arrive there completely. The third law of thermodynamics holds like an unmovable wall. The closer you travel toward absolute zero, the harder it becomes to keep cooling. The final scraps of motion cling stubbornly to matter like whispers you cannot silence. And even though this barrier exists, scientists still chase the goal. Piece by piece, degree by degree, they inch downward. And every time they step closer, the world of low temperatures grows stranger. Solids and gases begin to act like nothing in our ordinary lives. Gases collapse into unified states where every particle shares the same quantum identity. Metals lose all electrical resistance, conducting perfectly. Fluids learn to flow endlessly without slowing, as though friction itself has vanished. This is not just a scientific novelty. The fact that absolute zero exists as a concept changes how we see everything else. It tells us there is a floor beneath all the restless energy of existence, a kind of cosmic silence that everything leans toward but never fully reaches. And this silence forces us to ask unsettling questions. If the universe has a temperature it can never touch, what does that say about its limits? About time itself, if motion one day could be slowed to almost nothing? Because time is tied to motion in ways we often overlook. The hotter something is, the faster its particles collide, the more events occur each second. Imagine pulling everything down to absolute zero, where motion halts and collisions end. What would time resemble then? Would seconds still pass if nothing changed during them? These are not only late-night questions. In laboratories, scientists creep down to billionths of a degree above this unreachable zero. They do not expect to cheat the laws of nature, but to witness what happens when the world we know is stripped away. And every single time, reality behaves in ways that appear almost alien. The closer we get, the more the universe seems to turn itself inside out. Even as we chase this number, even as we inch closer to this impossible line, absolute zero remains more of an idea than a destination. It is the ultimate boundary, the reference point that gives meaning to all warmth. Without it, our scales would float without anchor. It is not simply a cold value, it is the measure by which all others stand. And in that sense, this number that should not be reachable is the very one that holds the whole structure together. So we keep descending, following step by step, like chasing a horizon that forever retreats. Every experiment draws us closer, but never close enough to erase the final gap. And within that gap, the most fascinating discoveries hide. Because if absolute zero were just another place we could arrive at and cross off a list, it would lose the very mystery that makes it worth chasing. Instead, it stays out there, untouchable, shaping everything around it while remaining forever beyond our reach. And this is where the story deepens. For as we keep moving downward into this silence, the world begins to lose its familiarity. It is not the falling numbers on the thermometer that change things. It is the fact that every step down strips away another layer of reality we once thought we knew. Near absolute zero, temperature itself begins to dissolve into something more like an idea, a countdown into a place where all the busy energy of the world fades into stillness. If absolute zero is the bottom of the scale, then this is the part of the journey where the scale itself begins to feel unreal. The phrase absolute zero almost sounds as though it was invented as a dare, a number so extreme it hovers on the edge of meaning. Minus 273.15 degrees Celsius. Not a fraction warmer, not even the faintest trace of heat left within it. Yet it is not simply cold. It is the border where cold, as we know it, ceases to function. A strange, unreachable frontier where temperature itself becomes a concept we can barely imagine. For most of our lives, temperature feels simple. We live among warm blankets and cool breezes, steaming cups of coffee and icy hands on winter mornings. Numbers we can make sense of. 40 degrees feels sweltering, 0 feels bitter, and we think we have seen the whole scale. But the truth is our everyday experience only brushes the surface of what temperature really represents. Temperature is not a sensation, it is movement. A measure of how much the smallest building blocks of matter are pushing and colliding like an invisible crowd. When things warm, those particles strike harder, spin faster, and vibrate with more energy. When they cool, the motion slows. But here is the strange twist. That slowing has no natural stopping point. There is no final rung, no ground floor to land on. Instead, every step downward costs more energy to extract than the one before it, until you approach a point where each fraction of a degree becomes an enormous effort. That is where you meet the idea of absolute zero. This concept did not appear overnight. It came from the slow progress of science centuries ago, when humans first began to realize that heat was not a substance you could pour or store like water, but rather something tied directly to motion. Figures like Lord Kelvin, who gave us the scale that carries his name, realized that if heat is motion, then there must be a boundary where motion itself ends. If motion ends, then temperature must end as well. That number became 0 on the Kelvin scale, not as a mere convenience but as a border etched into the structure of reality. Yet here is the mischievous truth. While this number has a name and a neat place in textbooks, the universe will never let us touch it. No matter how ingenious our machines become, no matter how many lasers or magnetic traps we build, we will never arrive there completely. The third law of thermodynamics holds like an unmovable wall. The closer you travel toward absolute zero, the harder it becomes to keep cooling. The final scraps of motion cling stubbornly to matter like whispers you cannot silence. And even though this barrier exists, scientists still chase the goal. Piece by piece, degree by degree, they inch downward. And every time they step closer, the world of low temperatures grows stranger. Solids and gases begin to act like nothing in our ordinary lives. Gases collapse into unified states where every particle shares the same quantum identity. Metals lose all electrical resistance, conducting perfectly. Fluids learn to flow endlessly without slowing, as though friction itself has vanished. This is not just a scientific novelty. The fact that absolute zero exists as a concept changes how we see everything else. It tells us there is a floor beneath all the restless energy of existence, a kind of cosmic silence that everything leans toward but never fully reaches. And this silence forces us to ask unsettling questions. If the universe has a temperature it can never touch, what does that say about its limits? About time itself, if motion one day could be slowed to almost nothing? Because time is tied to motion in ways we often overlook. The hotter something is, the faster its particles collide, the more events occur each second. Imagine pulling everything down to absolute zero, where motion halts and collisions end. What would time resemble then? Would seconds still pass if nothing changed during them? These are not only late-night questions. In laboratories, scientists creep down to billionths of a degree above this unreachable zero. They do not expect to cheat the laws of nature, but to witness what happens when the world we know is stripped away. And every single time, reality behaves in ways that appear almost alien. The closer we get, the more the universe seems to turn itself inside out. Even as we chase this number, even as we inch closer to this impossible line, absolute zero remains more of an idea than a destination. It is the ultimate boundary, the reference point that gives meaning to all warmth. Without it, our scales would float without anchor. It is not simply a cold value, it is the measure by which all others stand. And in that sense, this number that should not be reachable is the very one that holds the whole structure together. So we keep descending, following step by step, like chasing a horizon that forever retreats. Every experiment draws us closer, but never close enough to erase the final gap. And within that gap, the most fascinating discoveries hide. Because if absolute zero were just another place we could arrive at and cross off a list, it would lose the very mystery that makes it worth chasing. Instead, it stays out there, untouchable, shaping everything around it while remaining forever beyond our reach. And this is where the story deepens. For as we keep moving downward into this silence, the world begins to lose its familiarity. It is not the falling numbers on the thermometer that change things. It is the fact that every step down strips away another layer of reality we once thought we knew. Near absolute zero, temperature itself begins to dissolve into something more like an idea, a countdown into a place where all the busy energy of the world fades into stillness. When matter is pushed to this boundary, familiar categories fall apart. Solids may behave like liquids, liquids may behave like gases, and gases may collapse into quantum clouds that blur the distinction between individual atoms. Scientists call these Bose-Einstein condensates, and they are often described as the fifth state of matter. But that description hardly captures their ghostly quality. Imagine countless atoms moving in absolute synchrony, losing their independence and blending into a shared existence. It is as though a room full of dancers stopped moving individually and began swaying as one vast body, every motion perfectly linked. At this temperature, the universe itself reveals a preference for unity over individuality. This strange unity also appears in other ways. Some materials lose all resistance to electricity, allowing currents to flow endlessly without weakening. These superconductors open pathways to technology that feels futuristic, from magnetically levitated trains to powerful quantum devices. Yet these wonders are not separate from the cold. They are gifts of the cold. They are properties the universe hides until we reach these shadowy levels of temperature. At absolute zero, it is not only atoms that grow quiet. It is as though entire laws of physics learn to whisper their secret alternatives. And when fluids become superfluids, they astonish even the most seasoned scientists. In this state, liquid helium, for instance, flows without friction. It can climb the walls of its container, defying gravity, moving as though ordinary physics has been set aside. To watch a superfluid is to see something both unsettling and beautiful, a form of matter that refuses to obey. This is what happens when you strip away warmth and approach silence itself. Matter no longer plays by the rules written for the world we know. Instead, it creates new rules, rules that can only be glimpsed in the deep quiet at the edge of zero. So while the pursuit of absolute zero may never end with arrival, the journey itself reshapes what we know. Each fraction of a degree closer peels away another mystery, exposing layers of behavior that feel more like poetry than physics. And in the quiet of these discoveries, we find a reflection not only of matter but of ourselves. For in some way, we too are creatures of motion, constantly vibrating with thought, action, and life. And just as atoms slow in the cold, perhaps we too can find meaning in stillness. That is why, even though the chase for absolute zero is a scientific quest, it also carries a quiet echo for anyone listening closely. It whispers that there are truths we can only uncover when we slow down, when we let the noise of ordinary life fade, and when we learn to sit calmly within the silence. When we pause here, hovering just above absolute zero, It is as if the universe itself begins to reveal hidden chapters. The ordinary behaviors we rely on dissolve, leaving behind strange whispers of another reality. We see condensates that move as a single entity, fluids that flow without end, and metals that carry electricity with flawless perfection. These states of matter are not simply curiosities for textbooks. They are glimpses of what lies beneath the surface of everything we know. The deeper we travel into this cold, the more the universe reminds us that its rules are not fixed but flexible, bending into shapes that ordinary warmth conceals. At this edge, what stands out most is how silence becomes meaningful. When atoms quiet their endless dance, when the frenzy of constant collisions drops to near nothing, the very idea of temperature seems to dissolve. We realize then that temperature is not a property of things but a measure of movement itself. Strip away that motion, and you are left not with nothing but with something new, something delicate and uncanny. It is a reminder that what we take for granted in the everyday world, the comfort of warmth, the sting of cold, the endless rhythm of energy flowing through our lives, is only a surface effect of a far deeper truth. Scientists push toward this point not out of idle curiosity, but because these strange behaviors offer doors into technology that could shape the future. The dream of quantum computers, machines that could solve problems beyond the reach of classical machines, depends on insights learned in this frozen realm. Superconductivity, with its promise of lossless energy transfer, offers visions of power grids that never waste energy, of trains gliding without friction. And even the search to understand the earliest moments of the universe, how the cosmos began, how matter first arranged itself after the Big Bang, borrows knowledge from experiments chilling atoms near this unreachable silence. It is fascinating to consider that while the absolute zero line is impossible to reach, its shadow influences so much of modern life. We carry its echoes in the precision of atomic clocks, in the operation of electronics, and in the very structure of modern physics. It is not only a number on a thermometer. It is the hidden stage on which some of the universe's strangest dramas unfold. And yet, perhaps the most profound lesson absolute zero offers is not technological but philosophical. It tells us that there is always a limit to motion, a horizon to energy. We live in a world where everything seems in constant flux, where change defines our every breath and heartbeat. But absolute zero sits there, unreachable but certain, reminding us that there exists a stillness deeper than any we know. A stillness so complete it seems to defy time itself. And when scientists creep closer to it, when their instruments cool gases to billionths of a degree above that unreachable floor, they are not only studying matter, they are, in a way, studying silence. Think of it like approaching the quietest pause in a symphony. The instruments grow softer, the notes thin, until at last there is a moment so hushed that the silence itself feels alive. That is what absolute zero represents, the pause that underlies the universe, the place where even energy takes a breath. And in that pause, strange harmonies emerge. Particles align, quantum fields reveal themselves, and matter bends into unfamiliar forms. The silence, it turns out, is not empty. It is full of secrets waiting to be heard. It is worth remembering, too, that absolute zero is not simply the bottom of cold, but the boundary of what we can measure. Beyond it, the very idea of temperature collapses. Negative temperatures, in certain quantum systems, become possible not because they are colder, but because they defy the ordinary meaning of heat. Atoms can be coaxed into states where adding energy makes them more ordered rather than more chaotic. In such bizarre cases, negative temperatures are paradoxically hotter than infinite heat. This is the strange poetry of thermodynamics, that as we pursue silence, we find new definitions of sound. So the descent continues, not in physical steps but in intellectual ones. Each experiment, each laser trap cooling atoms closer to stillness, is another page in a story that stretches back centuries. And the end of that story may never come because the laws of nature forbid it. But perhaps that is the point. Absolute zero is not a destination. It is a compass point, a reminder that in chasing the impossible, we learn more about what is possible. And every step closer draws us into a deeper appreciation for the complexity of reality. As you listen and drift with this thought, imagine standing at that edge. Around you, no winds blow, no particles jostle, no heat flows. The universe holds its breath. In that imagined silence, you might find not emptiness but clarity, a reminder that stillness has its own form of knowledge, that by slowing down, by letting motion ease, the universe opens doors it keeps hidden in its louder, warmer states. This is the gift of absolute zero. Not the cold, not the unreachable boundary, but the quiet lessons it leaves us with as we wander close to its shadow. As we move onward, the idea of absolute zero continues to cast its strange light. It is less a number, more a boundary that forces us to rethink what it means to exist at all. Scientists once thought of heat as a substance, something you could pour or contain. But as centuries of study revealed, heat is motion, energy in constant exchange. And motion, it seemed, had no end. Until the idea of absolute zero appeared, the silent point where all that motion might vanish. The very thought was unsettling, yet it changed science forever. Every day, we are surrounded by the reminders of motion. The way steam drifts upward from a hot drink, the way ice melts and flows into water, the way our own bodies produce warmth in every heartbeat. We do not think of it as billions of atoms colliding, spinning, and vibrating endlessly, but that is what it is. And absolute zero asks, what happens if we take that all away? What does matter become when its dance slows to silence? The answer has carried us into one of the most fascinating regions of modern physics. Consider again the Bose-Einstein condensate, that state of matter where individual atoms blur into a shared identity. It is not just a curiosity, but a window into a world of quantum, behavior magnified to scales we can see. Quantum mechanics usually hides behind the scenes, its strangeness confined to particles too small for the eye to detect. But near absolute zero, the quantum world steps into view. Entire clouds of atoms move as one, showing us that individuality is not the rule of nature, but only a convenience at ordinary temperatures. Beneath it lies unity, a deep coherence waiting to surface. Superconductors and superfluids tell the same story in different languages. They remind us that resistance and friction, two forces we assume are fundamental, are not inevitable. They are products of warmth. Strip the warmth away and matter learns new tricks. Electricity flows endlessly. Liquids glide without losing energy. The universe, it seems, contains efficiencies that everyday temperatures keep hidden. These efficiencies are glimpses into what could shape the future, powering technologies that today still feel like dreams. And as we drift through these thoughts, it is worth pausing to see how closely tied this unreachable zero is to human life. Because though we will never reach it, the pursuit of it shapes technologies you already rely on. GPS satellites, which depend on atomic clocks to tell time with extraordinary precision, exist thanks to discoveries born from studying atoms at ultra-cold levels. The medical imaging machines that peer into our bodies use superconducting magnets that only work because of lessons learned in the cold. Even the transistors in computers carry traces of this knowledge. Absolute zero in its silence has touched the very fabric of modern living. But there is another layer here, a lesson about boundaries. Humans are explorers by nature. We sail seas, climb peaks, send machines beyond planets. Each horizon we chase eventually becomes familiar. But absolute zero remains the kind of horizon that cannot be crossed. It is written into the structure of the cosmos as unreachable. And strangely, it is that impossibility that makes it so compelling. Because in chasing what we cannot touch, we learn the most. The attempt itself reshapes knowledge, and perhaps that is the real gift of absolute zero. Philosophers sometimes describe it as a kind of perfection, not perfection of form or beauty, but of stillness. a perfection that cannot exist in reality, only in idea. And perhaps that is why it captures our imagination so deeply. We live in a world of noise, change, and movement. Yet hidden at the bottom of the temperature scale is the suggestion of an ultimate calm. A calm so absolute it defies experience. And though we cannot live there, we can imagine it. And sometimes imagination is as powerful as arrival. As scientists inch closer to it, they learn to use light and magnetism like sculptors' tools, slowing atoms bit by bit. Lasers tuned precisely can nudge particles into stillness, lowering their motion until the temperature approaches billionths of a degree above zero. Each step downward is harder than the last, each improvement and achievement measured not in leaps but in fractions. But within those fractions, the universe shows its hidden side. New behaviors emerge. Matter bends in ways that rewrite textbooks, and always the horizon remains ahead, unreachable but luminous. And so we continue. Absolute zero is not simply the end of a scale. It is a teacher. It shows us that the universe hides its strangest truths in the quietest corners. It shows us that silence is not empty, but filled with patterns we cannot see at higher energies. And perhaps most of all, it shows us that the pursuit of knowledge is not always about reaching the destination, but about the discoveries we make on the way. In this sense, absolute zero is not failure but triumph. For by failing to arrive, we succeed in uncovering mysteries that transform how we see everything else. So picture it once more. Picture the stillness where no vibration stirs, where the dance of atoms has ended. Picture the silence that does not feel like absence, but like the deepest presence of all. That is the vision absolute zero offers us. It is not a place to go, but an idea to carry. And as we drift through the night, it stays with us as a reminder that within the universe lies a stillness so profound it shapes everything else, even though it can never be touched. As we descend further, the cold draws us into stranger and stranger landscapes of physics. Absolute zero is unreachable, yet its presence shapes the path of discovery like a guiding star that can never be touched. Every step closer reshapes our view of matter and of reality itself. The pursuit is not just technical, it is philosophical. It forces us to ask what it means for motion to end, for energy to vanish, for silence to become absolute. Think of the effort required to cool matter near this edge. Ordinary refrigerators work by moving heat from one place to another, compressing and expanding gases, letting energy flow outward. But to reach billionths of a degree above absolute zero, scientists must invent new tools. Lasers are used not for burning or heating, but for slowing particles, tuning their frequencies so that each atom absorbs light and loses motion. Magnetic traps are built to hold gases without touching them, so that no warmth leaks in. These machines are not merely coolers, they are instruments for sculpting stillness. And with them, researchers descend step by step into a domain where the universe behaves like nowhere else. In this realm, strange things happen to light itself. When matter is cooled into condensates, photons can be slowed down dramatically. In some experiments, light traveling at its usual unimaginable speed is reduced to a crawl, creeping along at walking pace. In others, it is stopped entirely, held still within a cloud of atoms as though captured in a frozen moment. Light, the fastest thing we know, can be slowed or even paused by the quiet of extreme cold. This alone reminds us how surreal the boundary of zero truly is. The deeper we move, the more we discover that familiar definitions unravel. Heat is not simply the comfort of warmth or the pain of burning, but the collective motion of invisible actors. Cold is not simply the absence of heat, but a path into hidden stages of matter. Near zero, atoms reveal their quantum nature openly, as though the temperature itself removes their disguises. And in this exposure, the world feels rewritten. Superconductivity becomes a natural state. In metals that normally resist current, electrons pair up, gliding effortlessly through crystal lattices with no loss of energy. These pairs are like dancers moving in perfect synchrony, unhindered by obstacles that normally scatter them. This is not just efficient electricity. It is the revelation that resistance, something we thought unavoidable, is not fundamental. It is contingent on warmth. Strip that warmth away, and electricity learns to flow perfectly. Superfluidity, too, becomes less like science and more like art. To see helium climbing the walls of its container, defying gravity, is to watch the laws of physics rewrite themselves before your eyes. To imagine a liquid flowing forever without friction is to imagine a world without loss. And though these behaviors seem alien, they remind us that nature contains possibilities beyond our ordinary grasp. The stillness of zero does not deaden matter, it awakens it into new forms. These marvels are not distant curiosities. They influence technologies shaping our lives. Magnetic resonance imaging relies on superconducting magnets born from cold. Particle accelerators probing the deepest structure of matter use the same principles. The dream of quantum computing, where information is stored and processed in ways that defy classical logic, relies on insights gathered in ultra-cold laboratories. The frontier of zero quietly powers the frontier of tomorrow. Yet for all its uses, absolute zero remains more than a scientific target. It is a mirror for our imagination. To think of a silence so perfect, of a stillness so complete, is to reflect on our own lives. We are creatures of motion, our hearts beat, our minds race. Our world never ceases its endless spin. But somewhere, even if unreachable, lies the suggestion of another way of being. A way defined not by motion but by calm. And perhaps that is why this pursuit feels so poetic. It is not only about physics, it is about longing for stillness. So as we drift deeper into the night, picture the boundary once more. Picture the world just above absolute zero, where atoms blur into unity, where light slows to a crawl, where currents glide forever, where fluids rebel against gravity. It is not emptiness, it is a hidden fullness, a reminder that even in silence, the universe hums with possibility. And though we may never touch the line itself, the act of moving closer reveals truths that reshape everything we know. Absolute zero, in its unreachable quiet, becomes one of the loudest teachers of all. As we continue, the pursuit of absolute zero becomes like a meditation on the universe itself. It is a reminder that the cosmos holds boundaries that we cannot cross, but those boundaries still shape everything within them. Just as the horizon gives meaning to the sky, absolute zero gives meaning to heat, motion, and energy. Without it, the scale of temperature would float anchorless, lacking a point of reference. With it, we see not only the structure of matter but also the limits of our reach. The machines that bring us closer to this silence are among the most delicate ever built. They work in layers, each step stripping away a little more energy, guiding atoms into stillness. First, conventional cooling methods bring materials low. Then, magnetic fields and lasers take over, each interaction tuned with astonishing precision. Particles are slowed until their speeds drop to almost nothing, drifting in ghostly traps. And as they do, the familiar world vanishes. Instead of behaving like tiny billiard balls, the atoms reveal their quantum nature, acting like ripples, waves, and patterns. It is as though cold itself pulls back a curtain, letting us glimpse the deeper play of the universe. What we find behind that curtain is not chaos but order. At ordinary temperatures, the world is noisy, filled with random collisions. But near zero, randomness drains away. Patterns form, particles align, entire clouds of matter synchronize. There is something profoundly calming about this idea, that beneath all the noise of existence, there is a hidden order waiting in the quiet. Absolute zero does not erase motion, it transforms it into unity. That unity expresses itself in many strange forms. In superconductors, electrons pair up, moving without resistance. In superfluids, liquids defy gravity and friction. In condensates, atoms merge into one identity. Each of these states reminds us that the universe is not bound by the rules we experience daily. Warmth hides possibilities, but stillness reveals them. It is as if silence gives matter permission to sing in a new voice. Even the definition of temperature shifts. Normally, we think of it as a measure of how fast particles move. But in these extreme experiments, temperature becomes a measure of how aligned particles are, how much order exists in the system. Negative temperatures, paradoxical though they sound, are hotter than any positive temperature because they describe systems where energy is inverted, where order emerges from energy instead of dissolving into chaos. These discoveries challenge not only our sense of physics, but also our intuition, forcing us to accept that the universe is stranger than we imagine. This strangeness has practical consequences too. Technologies inspired by ultra-cold physics are shaping the future. Quantum computers rely on delicate states of matter stabilized in extreme cold. Magnetic resonance imaging, a staple of medicine, depends on superconducting magnets. Even the chips in everyday electronics trace their lineage to experiments that probed the limits of temperature. Absolute zero may be unreachable, but its influence flows through our lives in ways we barely notice. And yet, perhaps the most profound effect is not technological but philosophical. To think about absolute zero is to think about stillness. It asks us to imagine a world without motion, without change, without time as we know it. This is not simply physics, it is reflection. In our noisy, restless lives, the idea of such stillness feels almost spiritual. It suggests that somewhere, even if only as an idea, there is a place where everything is calm. So as we drift further into this night of thought, picture the silence again. Picture the atoms slowing until they blur into one. Picture light, slowed and trapped, waiting in stillness. Picture currents flowing without end, fluids moving without resistance, matter revealing its hidden symmetries. That is the vision absolute zero offers. It is not an end, not a number, but a mirror held up to the universe. And in its reflection, we see both the strangeness of reality and the beauty of silence. The closer we drift toward the idea of absolute zero, the more it begins to feel like an unfinished story written into the universe. Every step downward reveals another secret, yet the final page remains sealed. This is part of its beauty. It invites pursuit without granting completion. And in that pursuit, science finds not only answers, but also questions that reshape our understanding of everything else. At ordinary scales, heat feels simple. It is the warmth of the sun on your skin, the chill of ice against your hand. But step into the framework of physics, and heat becomes something entirely different: motion. Countless atoms, unseen and ceaseless, pushing, colliding, vibrating. Temperature is the measure of that dance. Absolute zero, then, is not just a cold point. It is the silence where the dance stops. The notion is haunting because it strips away the familiar, leaving us face to face with what happens when motion disappears. What emerges is not emptiness, but transformation. Superconductivity, superfluidity, condensates. These are not simply phenomena, but states of being hidden within matter, waiting for stillness to call them forth. They remind us that the everyday world, warm and chaotic, hides layers of potential. In the cold, those layers open like secret passages. It is no wonder that the laboratories chasing absolute zero are sometimes described as gateways. Within them, reality performs experiments on itself. Consider again the slowing of light, one of the most striking demonstrations near this edge. Light, the cosmic speed limit, can be brought almost to a halt within ultra-cold matter. That fact alone is staggering. It tells us that speed, time, and space are not untouchable absolutes, but qualities the universe can bend when conditions change. To hold light in stillness is to hold time in suspension, even if only for an instant. And in that instant, we glimpse the pliability of reality. Negative temperatures only deepen the strangeness. They remind us that our intuition is limited, that the simple picture of hotter and colder fails at the edges. In certain quantum systems, adding energy brings order instead of disorder, flipping the very logic of heat. Such states are not colder than absolute zero, but paradoxically hotter than any heat we know. This inversion teaches us that the laws of thermodynamics are not static walls but landscapes with hidden trails, waiting to be explored. And yet, even with all of these marvels, the journey toward zero is marked most by humility. Every experiment edges closer, but none arrives. The third law of thermodynamics stands like a guardian at the gate, reminding us that nature keeps some doors closed. Still, the closer we come, the more it seems that the closed door is not a denial but an invitation to explore without expectation of arrival, to learn without needing to conquer. This is why absolute zero resonates beyond the laboratory. It is not only a number for physicists, it is an idea for everyone. It whispers of silence beneath the noise, of unity beneath the chaos, of order hidden beneath disorder. It suggests that even if perfection is unreachable, the pursuit of it is meaningful. And perhaps that is why it feels so calming to think about. It offers us a vision of stillness we cannot touch but can imagine. So picture it once more. A place where the clamor of motion fades into near silence, where particles blur into waves, where light itself pauses in its flight. It is not a destination but a reflection. Absolute zero reminds us that the universe holds mysteries not to be solved, but to be lived with. And in that quiet reminder, we find a kind of peace. As the path carries us further into this imagined silence, the meaning of absolute zero grows even richer. It is no longer only about numbers or the mechanics of cooling. It is about the idea of reaching the edge of what is possible. To approach absolute zero is to approach a frontier where the familiar dissolves, and in that dissolution, new truths emerge. Consider the layers of discovery that have unfolded along this pursuit. Each attempt to cool matter closer to stillness has peeled back something new. Superconductors that lose all resistance, superfluids that defy gravity, condensates where individuality disappears. Each is a reminder that the universe hides possibilities until conditions call them forth. And those conditions are not warm and chaotic, but calm and ordered, found only in the quiet shadow of zero. What is striking is that this pursuit does not weaken with impossibility. Quite the opposite. The very fact that we cannot arrive makes it all the more meaningful. Science thrives on questions that never end, horizons that never settle. Absolute zero offers precisely that kind of horizon. It is a destination written into the laws of physics as unattainable, and yet it continues to draw us closer, reshaping our understanding with every step. This has echoes beyond the laboratory. In life, too, we often chase horizons that remain just out of reach: peace, perfection, stillness. We may never arrive, but in the act of moving toward them, we discover things we would not have seen otherwise. The pursuit itself becomes the reward. Absolute zero mirrors this truth, reminding us that impossibility can be just as fruitful as success. And then there is the question of time. Near zero, time itself seems to waver. Processes freeze, collisions halt, randomness fades. Imagine a world where seconds stretch endlessly, not because clocks change, but because nothing within them happens. It is unsettling, and yet it holds a strange calm. To imagine time without change is to imagine silence given form. And that silence is precisely what absolute zero represents. A reminder that time is not an absolute flow, but a measure of motion. These reflections find their way into technology, too. Without ultra-cold experiments, we would not have many of the tools we depend on today. The resonance of atoms at near-zero temperatures allows us to build clocks so precise that they lose less than a second over millions of years. Superconducting magnets enable machines that peer into the body with clarity once unimaginable. And quantum computers, still in their infancy, rely on the behaviors revealed in these frozen realms. What was once a philosophical idea has become a practical foundation for modern life. And still, the journey goes on. Laboratories continue to refine their techniques, trapping atoms in ever more delicate ways, cooling them to fractions of a billionth of a degree above zero. Each success is a triumph of patience and precision. Each experiment is a step further into silence. Yet the horizon does not move. The barrier remains, and in that barrier lies meaning. For if we could arrive, the story would end. But since we cannot, the story continues, endlessly unfolding. So let the thought linger. Absolute zero is not only a temperature but a symbol. It is the unreachable boundary that shapes everything above it. It is the reminder that silence exists, even if we cannot touch it. It is the whisper that perfection, though impossible, can still guide us. And as we drift further into this night of reflection, absolute zero becomes less of a number and more of a companion. The quiet presence reminding us of the stillness hidden beneath motion. As the story deepens, absolute zero begins to feel less like a scientific abstraction and more like a philosophy of stillness. Every description of it, every experiment that brushes its edge, paints it as the quiet heart of reality. In daily life, we are surrounded by movement. Air swirls, blood flows, voices echo. Even when we sit motionless, atoms within us continue their restless dance. But absolute zero asks us to imagine something else entirely. A condition where all that motion is stripped away, leaving behind only silence. This is not an ordinary silence. It is not the absence of sound, but the absence of change. It is the silence of a universe without motion, without randomness, without time as we know it. To picture it is to picture a world where nothing stirs. And though that image may seem unsettling, it carries a strange serenity. For within it lies a vision of calm so complete that it feels almost like peace. The physics confirms what the imagination suggests. Atoms cooled close to zero reveal behaviors that border on the mystical. A gas becomes a single wave. A liquid learns to flow without end. A metal conducts without loss. The familiar categories that define our world blur together, merging into new states that defy ordinary description. These are not tricks or illusions. They are the universe showing its hidden face, a face that warmth normally conceals. What is most remarkable is how fragile these states are. A whisper of energy, a trace of heat, and the unity dissolves. The condensate scatters, the superfluid obeys gravity again, the superconductor gains resistance. The silence breaks. It is a reminder of how delicately balanced these worlds are, how close they hover to collapse. And yet, for as long as they last, they show us truths we would never otherwise know. This fragility also speaks to the human side of the pursuit. We too live in a balance between motion and stillness, chaos and calm. Just as a laboratory struggles to keep its atoms shielded from warmth, we struggle to keep our lives shielded from noise. And just as the experiments reveal hidden wonders in stillness, perhaps we too can discover clarity in our quieter moments. Absolute zero, then, is not only a physical idea, but a metaphor for a kind of peace we all search for. The paradox of absolute zero is that it is unreachable. The third law of thermodynamics holds firmly, ensuring that no matter how much energy we remove, a final trace of motion always remains. The door never opens completely. And yet, that impossibility is what gives it its meaning. If it were merely another destination, it would lose its mystery. Instead, it remains forever out of reach, an invitation rather than a conclusion. And perhaps that is the ultimate lesson. The universe does not always grant us endings. Sometimes it grants us horizons instead. Absolute zero is such a horizon, endless, unreachable, but always guiding. And as we chase it, we are changed. We invent new machines, discover new states, shape new technologies. We reshape not only our world, but our understanding of ourselves. The silence we pursue reshapes the noise we live in. So let this image linger. Absolute zero as the horizon of stillness. Not a place to go, but an idea to hold. A reminder that within the endless motion of life, there exists a deeper calm, even if we can never fully enter it. And that calm, like the horizon itself, is always just ahead, waiting to remind us of the quiet hidden within all things. The journey into the mysterious realm of absolute zero carries us deeper into the very heart of matter. It is not only about cooling atoms or lowering temperature. It is about peeling back the layers of the universe until only silence remains. Every experiment, every slow descent into colder states of being, acts like the removal of another curtain. Behind each curtain hides a truth that had always been there, waiting, but concealed by the noise of heat and motion. At ordinary temperatures, the world is alive with invisible commotion. Every breath of air, every solid wall, every drop of water vibrates with endless activity. Molecules race, crash, spin, and collide in a restless dance. This dance is constant, so constant that we do not notice it. It is the background hum of existence, the quiet chaos that builds the world we know. But when the temperature is lowered, that frantic pace begins to fade. Each step down slows the ceaseless collisions. Each degree stripped away draws the universe closer to stillness. Imagine this process as a crowd of people in a vast room. At first, the crowd is loud, each voice raised, each motion chaotic. Then slowly, the crowd softens. Voices drop, movement slows. People begin to sway together rather than clash. And then, near the lowest possible point, something extraordinary happens. The crowd no longer acts as individuals at all. They move together, unified, almost as though they have become one. That is what happens when atoms are pushed toward absolute zero. The noise of individuality dissolves into the harmony of unity. This is the beauty of the Bose-Einstein condensate, one of the strangest states of matter ever observed. In this condition, billions of atoms overlap into a single quantum wave. They stop being separate particles. They act instead as a single entity spread across space. It is as though matter abandons the idea of separation and chooses coherence. To look at such a condensate is to glimpse matter in its most profound form, not a collection of individuals but a single shared identity. This reveals something crucial about reality. At the root, the universe is not built of solid, separate pieces. It is built of waves, patterns, and probabilities. Warmth hides this truth by scattering atoms into randomness. But near absolute zero, that mask is removed, and the wave nature of existence rises to the surface. What was hidden within every grain of matter becomes visible when the universe is stripped of motion. And condensates are only one part of the story. Superconductors tell it in another language. At ordinary temperatures, metals resist the flow of electricity. Electrons crash into obstacles within the lattice of atoms, wasting energy as heat. But cool those metals to the edge of zero, and resistance vanishes. Electrons no longer scatter, they pair up, gliding together in perfect synchrony. Electricity flows without loss, without waste, endlessly. It is not just efficient, it is flawless. This shows us that resistance, something we once thought inevitable, is not fundamental. It is a symptom of warmth. When warmth disappears, perfection emerges. Superfluids carry this strangeness further. Cool helium near absolute zero, and it slips into a state where it no longer obeys gravity or friction. It creeps up the walls of containers. It flows forever without slowing down. No matter how narrow the opening, it squeezes through. Watching a superfluid feels like watching rebellion itself, matter ignoring the rules written for it. Yet it is not rebellion, but revelation. These rules were always there, waiting. Heat only drowned them out. Remove the heat and the quiet laws surface. Even light itself is pulled into this strange realm. Normally, light is the fastest traveler in the cosmos, racing at 300,000 kilometers per second. But in ultra-cold experiments, light slows. In some laboratories, it is reduced to the pace of a bicycle. In others, it halts entirely, stored within a cloud of atoms as though frozen in time. To hold light still, the very thing we trust as constant, is to glimpse how elastic reality truly is. If even light can pause, then nothing is beyond transformation. And yet for all these marvels, absolute zero remains untouchable. The third law of thermodynamics ensures it. No matter how carefully we cool, No matter how perfectly we trap atoms, a final trace of motion clings to matter. The universe does not let go completely. That door never opens, but perhaps that is what makes it meaningful. If we could arrive, the story would end. Instead, we forever approach, and in approaching, we discover. This paradox defines absolute zero. It is impossible, yet it gives us everything. It is unreachable, yet it shapes our world. Without it, we would not have atomic clocks measuring time with unmatched precision. Without it, we would not have superconducting magnets powering medical machines. Without it, we would not dream of quantum computers. Absolute zero, though never touched, leaves fingerprints everywhere in our lives. But beyond science, there is philosophy. Absolute zero reminds us that perfection exists only as an idea, stillness that complete cannot be entered. Yet by imagining it, by pursuing it, we reshape how we live. In our own restless lives, filled with noise and motion, the vision of absolute zero is like a reminder of peace. It whispers that calm exists, even if only as a horizon, and sometimes a horizon is enough. The pursuit of zero has always been like this. From the first musings of ancient thinkers about warmth and cold, to the experiments of Kelvin defining his scale, to the ultra-cold laboratories of today, humanity has been chasing silence. The closer we come, the stranger the discoveries become. And though we know the end can never be reached, we continue, because the journey itself is what matters. So let us pause and imagine it one more time. Imagine a universe without vibration. A universe where no atom spins, no molecule collides, no particle stirs. A universe resting in the deepest stillness. What does that look like? What does that feel like? Perhaps it is unsettling, but perhaps it is calming. For in that silence we might find not emptiness but fullness, not absence but clarity. Absolute zero is not just the end of a scale. It is a mirror held up to the universe. It shows us what lies beneath noise and motion. It shows us that stillness has its own lessons. And though we cannot stand there, we can carry its image within us. That image of silence so complete it reshapes matter and light may be the most powerful gift of all. The story of absolute zero continues to unfold like a long, quiet journey. By now, we see it not only as a number on a scale, but as an idea, a horizon at the edge of physics, one that shapes everything above it. And in chasing this horizon, humanity has uncovered truths that transform the way we think about matter, about time, and about ourselves. At its core, absolute zero is simple to describe. It is the point where motion stops. Heat is movement. Temperature measures how fast atoms and molecules collide, spin, and vibrate. To lower temperature is to slow this activity. To imagine absolute zero is to imagine a place where this motion vanishes completely. But the simplicity of that description hides the enormity of what it means. Because if motion ends, then what becomes of time, of energy, of reality itself? This is why the pursuit of absolute zero is more than science. It is philosophy dressed in equations. For centuries, people believed heat was a substance, a kind of invisible fluid called caloric. Only later did scientists realize that heat was not a thing but a behavior, not a material but a motion. That discovery changed everything. And in naming the point where motion ceases, we gave the universe a bottom, a floor beneath its endless fluctuations. That floor is absolute zero. But even though we can define it, we cannot touch it. The third law of thermodynamics makes sure of that. The closer we cool matter, the harder it becomes to draw out the last traces of motion. Each degree closer costs more energy than the one before. The final fraction clings to atoms like breath clings to glass on a cold morning. It will not release. And so we are left forever approaching, never arriving. Yet that approach is filled with wonders. In the frozen shadows near zero, matter reveals sides of itself that remain invisible at ordinary temperatures. Clouds of gas collapse into Bose-Einstein condensates, where individuality dissolves and atoms move as one. Metals lose their resistance, carrying electricity without loss. Liquids become superfluids, slipping without friction, flowing in defiance of gravity. These are not rare tricks. They are truths buried in matter, uncovered only when silence deepens enough to reveal them. The slowing of light in these experiments is one of the most astonishing examples. Light is supposed to be constant, the fastest thing in the cosmos, a cosmic speed limit no one can break. And yet, in ultra-cold laboratories, scientists slow light until it crawls, and in some cases, they bring it to a stop. For a moment, light itself is stored inside matter, held like a breath. This does not mean the speed of light in a vacuum changes, it remains the same. But it shows us that light, under the right conditions, can be paused, bent, reshaped. Even the most constant thing we know bows to the silence of near zero. This teaches us something humbling. The universe is not as rigid as we imagine. What feels absolute often hides elasticity. What feels permanent often carries exceptions. Absolute zero reminds us of this again and again. The laws of physics are not chains but patterns, and when conditions change, the patterns reveal new forms. Negative temperatures show this vividly. The phrase sounds impossible. How can a system be colder than the coldest possible point? Yet in quantum physics, negative temperatures exist, not as colder states but as inverted ones. They are paradoxically hotter than any heat we know, because they represent systems where adding energy increases order instead of chaos. They flip the script of thermodynamics. To think of them is to realize that even our most trusted scales can twist into unfamiliar shapes. And these discoveries are not locked in the laboratory. They spill into everyday life. The precision of GPS navigation, the clarity of MRI machines, the future promise of quantum computers. All are built on knowledge gained from studying ultra-cold matter. The unreachable silence of absolute zero has already written itself into the fabric of daily living. It shapes the tools we use, the medicine we trust, the technology that connects us. We cannot touch it, but we live inside its influence. Still, beyond science and technology lies meaning. Absolute zero represents a form of perfection, the perfection of stillness. It tells us that somewhere, at least as an idea, there exists a place without noise, without rush, without chaos. In our restless lives filled with constant motion, that idea is powerful. It is calming. To imagine a state where everything slows into silence is to imagine peace itself. And though it is unreachable, the act of imagining it changes us. This is why absolute zero resonates so deeply. It is more than an equation or a temperature. It is a metaphor. It reflects our human condition. We are creatures of motion, forever restless, forever moving. But within us, there is a longing for stillness. Absolute zero speaks to that longing. It whispers of calm at the heart of chaos, of silence beneath the noise. It suggests that the pursuit of peace, even if never complete, is still worthwhile. The pursuit itself becomes the reward. Scientists know they cannot arrive, but they try anyway. And in trying, they discover. The impossibility of absolute zero is not a failure. It is the very reason it matters. For in chasing it, we learn more than we ever would by standing still. The horizon pulls us forward, and in moving forward, we uncover truths that shape our world. So imagine again the silence of this unreachable place. Imagine a world where atoms no longer stir, where no vibration echoes, where light itself pauses in stillness. Imagine time stretched thin, slowed almost to nothing, because nothing within it changes. That is the vision absolute zero offers. Not a place to arrive, but a mirror showing us what lies beneath motion. And in that mirror, we see not emptiness but fullness, not absence but clarity. We see the hidden face of matter, the quiet laws of physics, the order beneath disorder. We see the horizon itself, unreachable but guiding. Absolute zero is not the end of a story but the story's greatest teacher. It shows us that stillness, even when impossible, can reshape the way we live within motion. The long pursuit of absolute zero now stretches before us like a path without end, and yet one that never feels wasted. To follow it is to peel back the universe, layer by layer, uncovering truths that warmth conceals. The story is not about final arrival. It is about what is revealed along the way, strange behaviors, hidden orders, and new ways of seeing reality. From the beginning, the idea of zero in temperature was radical. To suggest that motion itself could end felt impossible, almost absurd. And yet, the more carefully scientists measured heat, the clearer it became. Heat was not a substance, not a fluid, but motion, and motion could be slowed. The question then became, how far could it be slowed? Was there a final boundary? The answer was absolute zero. A point of silence built into the fabric of physics, a horizon of stillness no one could cross. What followed has been centuries of pursuit. Each generation found new tools, new techniques, new ways to press matter toward this boundary. Each step downward revealed a world stranger than the last. And though the final step has never been taken, the journey itself has been transformative. Near absolute zero, matter abandons the familiar. Gases collapse into condensates, particles overlap into waves, individuality dissolves into coherence. Metals shed their resistance, electrons glide without scattering, liquids slip into superfluidity, flowing endlessly, defying friction, even climbing walls. The world reshapes itself into forms that feel alien and yet are perfectly natural, natural in silence, hidden by noise. This is one of the deepest lessons of absolute zero. The universe is filled with possibilities we cannot see at ordinary scales. Warmth hides them, chaos drowns them out. But strip the energy away, remove the motion, and the hidden order surfaces. The pursuit of zero is not the pursuit of emptiness. It is the pursuit of revelation. Even light, the most constant traveler we know, bends to this revelation. In ultra-cold matter, light slows, its rush reduced to a crawl. In some cases, it stops, resting within atoms as though time itself has paused. This does not change the speed of light in a vacuum, but it shows us that under certain conditions, even the fastest thing in the cosmos can be held still. The silence of near zero proves stronger than our assumptions. And then come the riddles of negative temperature. At first, the phrase sounds nonsensical. How could something be colder than the coldest point? But quantum systems behave differently. In carefully prepared states, atoms can invert their order, creating conditions where energy adds harmony instead of chaos. These states are not colder than absolute zero. They are paradoxically hotter than infinity. Such discoveries show us that our everyday scales and intuitions are limited. At the edges, the rules rewrite themselves. But while the physics is remarkable, what lingers is the philosophy. Absolute zero is a boundary written into nature that we cannot cross. It resists our tools, refuses our ingenuity, holds firm no matter how precise we become. And yet, this resistance does not discourage us. It inspires us, for in chasing what we cannot touch, we learn. The impossibility of absolute zero becomes its greatest gift because it turns the pursuit into an endless source of discovery. This endlessness is mirrored in our lives. We too chase horizons we never fully reach: peace, perfection, clarity. And just like absolute zero, these horizons remain ahead of us, pulling us forward. The pursuit shapes us more than the arrival would. Absolute zero becomes a metaphor for our condition. We live in motion, restless, noisy. But within us lies the longing for stillness, for silence. And though we never fully find it, imagining it changes how we see the noise around us. This is why absolute zero resonates so deeply. It speaks not only to physicists but to dreamers. It whispers of silence at the heart of motion, of calm beneath chaos. It tells us that stillness is part of the universe's design, even if it is unreachable. And in imagining that stillness, we find a reflection of our own desire for peace. The laboratories chasing it know this paradox well. They build machines colder than space itself, using lasers as tools of stillness, magnetic traps as cages for silence. They lower matter to billionths of a degree above zero, closer than anyone thought possible. And each time the universe offers new revelations, condensates, superconductors, superfluids, frozen light. Each time the story deepens, and always the horizon remains ahead. It is worth pausing to think about what this means. If absolute zero could be reached, the pursuit would end. But because it cannot, the story never finishes. It is an infinite source of discovery. The very barrier that frustrates us is the reason we continue to learn. This is the hidden gift of impossibility. It ensures that curiosity never runs dry. And so we keep imagining it. Picture a universe stripped of vibration. No atom stirs, no molecule collides, no particle moves. Time itself feels suspended, stretched thin, because nothing within it changes. To imagine such a silence is unsettling, but also strangely peaceful. For in that silence lies the suggestion of perfection, not perfection of form, but of stillness. That perfection is unreachable, but it does not need to be reached. Its value lies in its pull. It shapes science, technology, philosophy, even imagination. It reminds us that beyond noise there is always calm, and beyond chaos there is always order. It tells us that the universe, though restless, carries silence within it like a secret heart. So the pursuit continues, not because we hope to conquer it, but because in following it, we uncover truths about the world and about ourselves. Absolute zero is not an end point. It is a guide, a teacher, a horizon that keeps us moving forward. It is the silence that gives meaning to motion, the unreachable calm that shapes the noise of existence. And as we let this thought settle, we realize something simple. Absolute zero is not only about physics. It is about perspective. It shows us that stillness exists, even if only as an idea. It shows us that impossibility can be more powerful than success. And it shows us that in chasing silence, we find meaning in the noise. The journey to absolute zero now reaches its quiet conclusion, though not its end. Because absolute zero itself has no ending. It is not a place to arrive, not a final destination that waits with open gates. It is a horizon, always beyond reach, always just ahead. Yet the pursuit of it has brought us here, to a place of reflection, a place where silence feels closer, and the meaning of stillness begins to unfold. From the very beginning, the idea of absolute zero has been more than a scientific concept. It has been a question, a challenge, and a mirror. What happens when all motion ceases? What lies at the bottom of temperature, beneath the chaos of heat and noise? The answers have been many, but none complete. Because each attempt to draw closer to zero does not close the story, it opens another chapter. This is the paradox of the coldest place. It refuses completion, yet it offers revelation. Every step downward reveals new wonders. Bose-Einstein condensates, where matter abandons individuality and merges into a single quantum identity. Superconductors, where resistance disappears and electricity flows forever without loss. Superfluids, where liquids defy gravity, climbing walls and flowing endlessly without friction. Light itself slowed, even stopped, as though time has been placed on pause. Each of these discoveries is extraordinary. Each is a truth hidden beneath the noise of warmth. And all of them exist not at zero itself, but in the shadow just above it. This teaches us something profound. The unreachable can still transform us. We may never arrive, but the journey reshapes our world. Without the pursuit of absolute zero, we would not have atomic clocks guiding satellites and navigation. We would not have superconducting magnets enabling medical imaging. We would not dream of quantum computers or technologies built on ultra-cold matter. The silence of zero, though untouchable, has already touched our lives. But its influence is not only technical, it is also philosophical. Absolute zero represents perfection, the perfection of stillness. It is a perfection we cannot reach, and yet we imagine it, we chase it, we learn from it. In this way, it becomes more than physics. It becomes a metaphor for the human condition. We live in motion. Our hearts beat, our thoughts race, our days fill with noise. Even in stillness, our atoms vibrate, our molecules collide. Yet within us, There is a longing for calm, for silence. Absolute zero reflects that longing. It whispers of peace beneath chaos, of unity beneath disorder. It reminds us that the pursuit of stillness, even if never complete, is meaningful. And perhaps this is why the idea of absolute zero feels so calming. To imagine a world stripped of all vibration, all noise, all change, is to imagine a peace we cannot know but can feel in thought. It is like imagining a pause in the endless song of existence, a single note held forever in perfect quiet. That vision is enough to soothe us, even if it remains beyond reach. The laboratories that chase this silence continue their work. They cool atoms to billionths of a degree above zero, using lasers, magnets, and patience. Each experiment is a triumph, not because it reaches the goal, but because it reveals another hidden layer of truth. Each one feels like pressing closer to the heartbeat of the universe, listening for the rhythm that lies beneath all motion. And though the barrier remains, the discoveries grow. If absolute zero could be reached, perhaps the story would end. But because it cannot, the story is infinite. It ensures that there will always be another horizon, another mystery, another discovery waiting in the silence. In this way, impossibility becomes a gift. It guarantees that curiosity will never be exhausted, that wonder will never run dry. So let us picture it one final time. The silence of the coldest place. A universe without vibration, without collision, without change. A world where time itself stretches thin because nothing within it stirs. It is unsettling, yes, but also comforting. For in that imagined stillness lies a perfection that gives meaning to all the noise above it. Absolute zero is not the end of temperature. It is the anchor that holds the scale in place. It is not emptiness. It is fullness, revealed in silence. It is not a failure to arrive. It is the reason discovery never ends. And as we reflect on it, we see not only the physics but the philosophy. We see a reminder that some horizons are meant to be chased, not reached. That some silences are meant to be imagined, not entered. And that even the unreachable can shape us. In this way, absolute zero becomes a teacher. It shows us that perfection, though impossible, is worth pursuing. It shows us that silence has its own lessons, hidden beneath noise. And it shows us that in chasing what we cannot touch, we uncover what we most need to know. So as the night deepens, let the thought settle. Absolute zero, the horizon of stillness, unreachable but ever present. A guide, a mirror, a reminder that the universe carries silence within it, shaping motion, giving meaning to noise. And as we drift into rest, we carry that vision with us. The calm at the bottom of all things, the stillness at the heart of reality.